Hello everyone. So in this video we will learn how to interpret a structure from the NMR data or vice versa. And one thing more I would like to mention over here that I am not going to explain any kind of concept regarding the NMR spectroscopy over here. If you want you can just write down in the comment box or I will make the separate video for that. So for the structure elucidation, I would like to say that it is a bitter truth that we will by heart some delta values corresponding to the functional groups. So let's see what are the functional group present in a given molecule and what are the delta values corresponding to that. So first is alkane region. For that the value started from 1 to 2 ppm. Or in alkane region also we have a three type of proton. First is methyl proton CS3, second is methine proton that is CS2, and third is methine proton that is CS type of protons. So you can just by heart this value also. The value of methyl proton is start from 0.9 or you can just say approximately 1 and just add 0.4 to it, you will get methine proton that is 1.3, and if you add zero point 0.4 more you will get methine proton that is 1.7. So the whole value start from 1 to 2, that is the range of alkane protons. Next is alkyne proton whose value starts from 2 to 3 ppm. All values are ppm. And next is alkene. Actually this is not alkyne, this is by mistake, this is alkene. Okay, so this is alkene proton whose value starts from 4 to 6. Next is aromatic protons. Aromatics are have a good range 7 to 8. Actually sometimes it may be started from 6.5 to 8.5 also. So I would like to tell you over here that these are the not exact values, these are the random or the average values, okay, which I have taken from the reference book, so you can just by heart. Next is aldehyde proton which start from 9 to 10. Next is acid which start from 11 to 12. Next is amide proton which start from 5 to 9 and it is a variable, and I will tell you what is the why it is called variable. Next is OH proton which also start from zero point 0.5 to 5. Next is NH proton, it also start from 0.5 to 5. Next is aromatic protons. This is not a aromatic proton, this is a actually type of phenolic proton, okay, this type of proton it is, this proton OH proton, and its value come under 4 to 7 ppm and it is also a variable. Next is a aniline proton, this type of proton it is aniline proton NH, okay, so this value come again 3 to 5. Okay, now last is enol proton. Enol proton, look at the value, it is more than 15. So this is the delta values corresponding to the functional groups. Now I tell you what is the meaning of variable. Actually these protons are the acidic protons, and since it is a acidic they can be exchanged and we cannot predict what will be the value of that corresponding protons. Okay, so that is why it is in, I have written over here is variable. The values of this type of protons depends upon the various things. One of the most important thing is solvent, which type of solvent if you are taking to record the NMR spectra. So if I talk about the amide proton, and if you will record its spectra in CdCl3, then its value come under the 5 to 9 range. But if you will use DMSO as a solvent, DMSO D6 as a solvent, so its value go beyond 12 ppm. Okay, so this type of effects which generally seen in the acidic type of protons, so we cannot easily predict the values of the acidic protons. So this is all about the chemical shift value corresponding to the functional group regions. So next is effect of electronegativity on delta value or chemical shift value. So we all know electronegativity is directly proportional to the delta value. That means as the electronegativity of an atom increases, delta value will also increases. Let us understand it by taking an example. Suppose if I give you two compounds CH3F and the second one is CH3Cl, and if I ask to you which have greater delta value, so what will you say about the delta values of these two compounds? Here in the first compound, we can clearly see that these three hydrogens are directly attached to the fluorine atom. And here it is directly attached to the chlorine atom. And we all know the electronegativity of fluorine is greater than the electronegativity of chlorine. So that means the delta value of fluorine will be greater than delta value of fluorine will be greater than delta value of chlorine. So this is the very easy example by which you can compare the delta value by remembering these equations only. We also know that the most electronegative elements are fluorine, oxygen, nitrogen, and chlorine. You can learn it by the synonyms of phone chloride. Okay, F for fluorine, O for oxygen, N for nitrogen, and Cl for chlorine. And its electronegativity values are: fluorine has 4, oxygen has 3.5, nitrogen has 3, and chlorine is approximately 3. So you have to just subtract zero point 0.5 from each, and you will get your answer what will be the electronegativity value of that. Okay, this is the order of electronegativity. Same order follows for the delta value. If it is connected to the CS3F, then the delta values of this will be 4.2 approximate, and if it is connected to CH3OH, then the delta value of this will be 3.5. These are the approximate value, not the real values. Okay, and nitrogen and chlorine both have the similar value, approx 3. Bromine is also left. Bromine has an electronegativity of 2.8, so their delta value will be 2.6 to 2.8. Apart from this, you can remember the delta values of attached hydrogen to the three most important compound which I am writing over here. The first is this type of compound, delta values of this type of compound. Second is methoxyprotons, O, CH3. Next is carbon attached to the aromatic system, this type of system where it is aromatic. It can be benzene or it can be any heterocyclic aromatic compound, and the carbon hydrogen attached to this carbon center. You just have to remember the values of this type of compound. So I'm writing the value, is just you must remember, because all of the organic molecule contain this type of functional group. So you have to remember the delta values of this type of hydrogen attached. So first is CS3, which is attached to the carbonyl center. Its value is approximately 2.5. Next is methoxy, whose delta value is approx 3.5. And next is this type of proton which is connected to the aromatic system. It is also have a 2.5 value. So by remembering this type of value, you can easily predict the NMR structure of any compound. So now let us summarize all the things which we have learned till now. So this is a very good chart which can self-explanatory what will be the delta value of a given compound. In the first, it is written that these are the protons: CS proton, CS2 proton, and CS3 proton. It is I have already told about this, so you can just remember these values. These are very important values. Okay. Now here are the some groups which are written in the tables, which are one shift, which will do shift by 1 ppm. These are the groups which will do shifting by 1 ppm. What are the groups? These are the groups: alkene, alkyne, nitrile, carbonyl, thiol, and sulfides. This will create a shift of 1 by 1 ppm. Let us take an example. Suppose we have a CH3 cyanide group over here. The base value of this is zero point 0.9, but because of the cyanide it will shift one more, so the whole value becomes 1.9. So its delta value approx will be 1.9. Shifting of 1 ppm are generally which contain a double bond or triple bond, or you can say a conjugated system which will shift a delta value by 1 ppm. Now the second shift is 1.5 ppm. These are the aromatic system, in which the carbon is attached to the aromatic system, or amine type of system, and sulfoxide type of system, which can create a shift of 1.5 ppm. Next shift is shift 2 ppm. Shift 2 ppm which contain a more electronegative atom like OH, amide, esters, and halides. These are the very important. 2 ppms are very important. OH, OR, amide, and all the halides and sulfones. These create a shift of 2 ppm. Next is shift of 2.5 ppm. The only compound which create a shift of 2.5 ppm is aryl ether. Next is shift of 3 ppm. It should be very electronegative atom attached to it, and it should be resonance also, like nitro group, ester group, and fluoro group. These are the creating shift by 3 ppm. Okay, so by remembering these value or shifting of functional group, you can easily predict the NMR structure of any compounds. So let us take some example to understand how we can calculate the NMR values by taking the base value and the shifting values of each functional group. So first example is ethyl acetate, which is very common, ethyl acetate. Okay, So let us draw the structure of ethyl acetate. First COO, CH2 and CH3, and here is acetate CH3. So first write down the types of protons. So these are the types of proton. First here, second and third. So you have to just predict the value of each type of CH3 group. So here you can see that this is a CH3 type of protons, and it is, so its base value should be approximately 1 to 1.2. Approximately it is 1.1 to 1.2. Okay, it is CS2. Its base value is approximately 1.3, but it is connected to the ester type of group. So it will increase by shift by 3. So approximately it should be resonate around 4.2. That is delta value. Approximately it should be 4.3. Okay. Next is acetate. Already I have told this type of carbonyl it should be approximately 2.5. So by this method you can easily predict the NMR values of any compound. Take another example. Let us take another example to gain your confidence. Okay. Suppose we have this type of molecule where we have a aromatic system like this, and CH2, again C double bond O, CH2, CH2, Cl. So first you have to identify the types of protons. First, this type, first, second, and third, and finally fourth aromatic types. So we all know the aromatics value will be 7 to 8 approximately. This will lie up in 7 to 8 region. Okay. Next is this type of CS2 proton. Its base value is approximately 1.3, but it is connected to the aryl system. It will create a 1.5 shifting of 1.5. Also it is connected to the carbonyl system. It will again decrease shift the value by 1. The total will be 1.3, 1 point, that is 2.8 plus 1, 3.8. So its value should be 3.8. And next is this type of CS2. This type of CS2 you can see clearly say it is a ester. So first its base value is 1.3. Now it is connected to the ester. So increment of 3, and it is also connected to the CH2 and Cl. So somewhat zero point 0.5 approximately it will, because of this Cl group, 0.5 approximately zero point 0.5 it will be shift the delta values. Okay. So the total value would be approximately 1.3 and 3, 4.3 and zero point 0.5, approximately 4.5 to 5. In between 4.5 to 5 it will resonate. So now it is connected to the Cl, so its base value is approximately 1.3, and chloro is connected to it. That means it shift the value by 2 units, so its value should be approximately 3.3. Look how easily you can predict the values of each type of proton present in a given organic molecule. So this is all about the NMR delta value prediction. Now we will give some real type of example where we have a spectra and we have to identify whether the compound is present or not.